heard about that, but I didn't know what happened.
Yeah, like all the money right now. Isn't really
Glad I didn't
surprising.
count on that.
I know.
Yeah. Yeah.
I mean,
Okay,
how
so
much
let's
actually
make
is?
this a little harder. Instead of going from 0 to 1, let's go from like 1 to 2.
You're taking this, right?
Yes, I am.
Okay, good.
So we've got y equals the square root of 4 minus x squared, and let's go from 1 to 2, okay? And let's pick 4, what do they want you to do here?
5, I think, for number 3.
Yeah,
5?
or, yeah. The upper and lower sum of 5.
Dude, I actually did the AP
Okay.
homework and really remembered
5, yeah. Okay, so n
That was
equals
easy.
5. All right, so this isn't a big deal. So, but we do need to. One thing we need to know here on this one is the graph increasing or decreasing on that interval?
Is that one decreasing?
It's decreasing, isn't it? Right? It's decreasing.
That's probably what we did.
Okay.
Wait, no.
Well, I mean, it's just going
No.
to switch your answers
God.
up then. Yeah.
You didn't get the right numbers.
Yeah, that's a good point.
Okay, so because it's decreasing, then we'll just calculate a left sum and a right sum, and honestly, one's going to be bigger, and that's going to be the upper sum, and one's going to be smaller, right? So let's do the right sum first, because that's always the easiest one, right?
Yeah,
So
you say so.
a sub, what do we call that? We called it a sub r, didn't we? A sub r is always what? Let's not even worry about this function. What is it in general?
A sub r.
It's going to be the sum of
A sub r.
all of the right rectangles. And what's going to be the area of a right rectangle? Its height times its width, right? What's the height going to be? F of what?
F of xi, or xi.
X sub I, right? Which is what in terms of A and B and
X sub I is a plus I delta x.
times delta x, right?
Yeah.
As I goes from 1 to 5 in this case, right? Okay, what's delta x going to be?
1/5.
1/5. 2 minus 1, the width of the interval is 1 divided by 5. Everybody agree?
Yeah.
So delta x equals 1/5. Okay. And our function is this, right? So we should be able to set this up. What's a?
0, 1.
1. Okay. So then what do we get? We get the sum of, we could take the 1/5 out front, right? So this guy, we're just going to do that with and get common factor of 1/5 for each term times f of 1 plus I times delta x is just I over 5. Everybody agree? Okay. So f of x is 4 minus x squared. What's f of hand? F of hand is what?
In what context?
Well, I mean, what's f of football? 4 minus football squared, right?
Yeah. Oh, well, yeah. So put all that 1 plus 1 or I to the 5th.
It is behind that. That's hand, right? And that's what's being squared. So then we're going to end up with the square root of 1 minus that hand squared, right?
1. Oh, wait, no. Shouldn't it be 4?
Oh, it's
Equal to 4 in the original equation.
4 minus.
4 minus, not 1 minus. Yeah, you're right. 4 minus. 4 minus hand squared. Now all we got to do is just add those up, right? So what's that going to equal? If I let this thing run from 1 to 5, first term I've got my 1/5 out front. What's first term going to be? If I is 1, what do I get? 1 plus 1/5 is 6/5.
Yes.
4 minus 6/5, so that's going to be, 20 minus,
6/5 is squared.
oh, it's squared, you're right. Okay, so 4 minus 36/25 So that's 100 minus 36 is 64/25 for the first one, right? Okay, plus I is 2.
Well, no, we didn't take the square root of that either.
Oh, we didn't, you're right. Square root of it. So that's 8/5.
Yeah.
Okay. Plus. Okay, try again. So now we got 1 plus 2/5 is 7/5.
49.
So 49,
So 51.
51. Good. So then we got the square root of 51/5, right? Okay, plus 3, so that's going to be 8, so 64, so that's 36. So that's going to be,
6/5.
yeah, 6/5 plus 4 is going to be
Root 19.5.
root 19. Is that what we get?
Yeah. 5.
Okay. Yeah, that's right. And then finally, 0. Right? So there's one sum. Okay, whatever that ends up being is decimal. Right? And that's going to be the lower sum, isn't it? Because that's the right sum. And it's decreasing now. Right? Okay, so then the left sum is really just going to be almost the same thing. What's the only difference if I do a left sum here?
I minus 1.
Yeah, I'm just going to have an I minus 1 times delta x, right? And so what's that going to do? So if we do, let's do this in purple. So if we were to sneak in a sub L up here, I get the same sigma, and I get f of now 1 plus I minus 1 over 5 times 1/5, right? Only difference when and so when I plug in 1, I'm just going to get, right, if that becomes an I minus 1 on top, if I plug in 1, I'm just going to get 4 minus 1 is 3, square root of 3. Everybody agree? For that first one. If I plug in 2, I'm going to get that. If I plug in 3, I'm going to get that. If I plug in 4, I'm going to get that. And if I plug in 5, I'm going to get that. Right? You see a shortcut?
You just figure out the first one.
Just figure out the first one. Yeah, because when we add up, you see how those kind of offset. We're just going to end up with a sub L equals 1/5 times just that, right? Yeah, make sense? Okay. All right. So enough of this nonsense. You guys getting tired of doing this? I am. I'm getting tired of
We
teaching.
can get it in the calculator.
What's that?
Did you guys put this in the quiz in the calculator?
I just
But
plug
I don't
the
know why
whole
it's
sigma notation in the calculator every time, honestly.
That's fine.
Well,
You
it
can.
Obviously didn't work this time.
Okay, well, let's try it. Let's try it. We'll just add those, just try those and add them up and see if they, real quick, see if they give you the right answer. You know, all we have to do is add the square root of 3 over 5 to that answer to get the other one. So the answer's, well, hold it, I made this one up. But you're telling me you didn't get the right answer. Did you get the wrong answer, Michelle, for the other one?
I have to figure out how to do it.
Well,
I can
River,
read
you
my
were
notes.
gone when we
River
were
and
at
Kylie
Kylie
both.
Oh,
Yeah,
you're
me and
nuts.
Kylie both couldn't get the right answer, like actually get to the number of the right answer.
Okay, well, let's do.
Trying to figure out how to set it up.
Let's do part of this. So the only difference was this one was 1 minus, and it went from 0 to 1, right?
Be able to do it then.
Yeah. Yeah, I'm pretty sure, I mean, I can double check.
Oh, no, I think I remember what my problem was. Let me just check something real quick and see how stupid I am.
We could help you out with that.
Alright. I mean, I'm sure.
Can't fit stupid.
Okay. I'm pretty tired of all that nonsense. I want to just teach you a better way to do it. Okay, so what I'm going to do is I'm going to teach you about a Riemann sum, right? Because we looked at an example, and you already have. Where's that thing? Oh, I can get rid of that thing. Okay. Here we go. Area under a curve.
Geogebra. A lot of
Okay, and so we looked at an example of, let's just take an easy one, f of x equals x squared. If I want to show the upper sum and the number of rectangles is only 1, if I'm adding up the area from 0 to,
Infinity real fast.
what am I doing? I'm doing it from 0 to 2, okay? Does that make sense? That's not very accurate, right? If I compare that to the lower sum, well, the lower sum, how is that the upper sum? Oh, no, we want to make the lower limit. Let's make the lower limit. I want to make the lower limit. Oh, here we go. I can change it up here. Never mind. Lower limit, let's make it 0. So the upper sum.
Again.
Always this last one.
The upper sum with one rectangle is not very good, is it?
No.
Okay. And the lower sum is really bad. It shows us 0, right? Okay, well let's at least bump it up to like 2 rectangles. So there's the lower sum, there's the upper sum. Still quite a ways off though, right? We're getting 5 for the upper sum, 1 for the lower sum. Somewhere in between is going to be the actual answer. The actual answer is
3.
2.67, I guess.
Around it.
Okay. So I could make this more accurate, would you agree, by increasing the number of rectangles? Like if I go up to 15 rectangles, now look, I'm much better. There's my lower sum, there's my upper sum on top.
Yeah.
I'm encapsulating that area more tightly.
How many rectangles can you get?
I can go up to a lot. I can go up to, what is that?
I can't see.
Let's see if I,
Yep.
yeah, why won't it show me?
That's too far over, right?
If I do that. I figured out a trick for doing that yesterday, where it'll show me.
Wait. Oh, over in the green doesn't say over on the left. On the chart. Which one? No, back over there on the left.
Oh, yeah. Over here.
100.
100, okay.
That's still point.
Yeah, but we're getting close, right? Okay, but what's our strategy? If we want to get an exact answer, you guys can tell me what the strategy is.
Take
now.
it to infinity.
I'm gonna take, but I can't plug infinity in. If I'm dealing with infinities, how do I accomplish that? I have to take a limit. I have to take a limit as the number of rectangles approaches infinity, right? Everybody agree?
When everything comes together.
Ah, okay, yeah, isn't it cool how it all comes together? So if we take a limit as the number of rectangles goes to infinity, then this is gonna work, right? We're gonna get an exact answer. So we should be able to do that. We have the skills to do that, right? So let's talk about the process. Okay, this process is called a Riemann sum, named after Dr. Riemann, I'm assuming.
Do we know who the doctor is?
Yeah, he was. So it's a Riemann sum. And let's think about how we could do this. Let's take, for example, well, let's do this one we just looked at here. Let's take the area under the curve y equals x squared from, what was it, from 0 to 2?
Yeah.
Okay. So we want to find f of x equals x squared, and we'll go from 0 to 2. All right. So then, let's think about the two sums we're gonna have here. We could either have a left sum or a right sum, but they're gonna converge, right? Which one's easier?
Left.
No, the right sum is easier because instead of having that I minus
yeah,
one, I
yeah.
just have an I, right? So let's just do the right sum. Let's calculate the right sum, and that's gonna be, let's write down the generic version first. So that's gonna be the sum of f of a plus I delta x times delta x as I goes from 1 to n, right? But we want to get an exact answer. So we're going to take the limit of this as n approaches infinity, right?
So
Right?
for the other side, would it be negative infinity? Am I jumping in? But like for the left area?
No, because the n, because we're letting I go to n. I is just the index variable. It's the number of rectangles only,
Oh, okay.
right?
Okay.
Right? So we're going to take the limit as n goes to infinity of that whole thing, right? Okay, well, let's think about that. I don't even have to draw a picture for this. We can do this. You know what, we saw a picture, right? We just saw a picture on the computer. What is delta x?
2 or no, 2 or
So it's going to be b minus a. So the width of the interval is 2, divided by the number of rectangles is n. Okay. So as n approaches infinity, predictably, what's the width of the interval approaching?
2.
No.
Oh,
It would
0.
be infinite smaller.
Well,
Yeah,
the-
so it approaches 0, doesn't it, right? Which makes sense. In order for this thing to fit perfectly above or under the curve, we don't even know which one we're dealing with. I guess we're doing a right sum, so it'd be above. It's a circumscribed sum. In this case, not that it matters. It's got to be infinitely narrow, right? Okay. So f of x is just x squared. A is 0, right? Everybody agree? So yeah, so what do we get then? So we get, this is equal to the limit as n approaches infinity of a plus I delta x is just going to become 0 plus I times 2 over n. So 2I over n. Everybody agree? And I'm going to square that. So I'm going to get the quantity sum of 2I over n as I goes from 1 to n, right? Times delta x I'll do one thing here. You'll see why in a second. And this becomes 2. Okay, so I is the index variable, so that is, this has to be squared, doesn't it? So that's the variable of the sigma. Does that make sense? Is the n a variable as far as the sigma is concerned? It is not. It is not. The n is a variable as far as what is concerned here? The limit. The limit encloses the sum, right? And so my question is it okay for us to put this 2 over n outside of the sigma?
Yes.
It is, because it's still contained inside the limit, isn't it? Right? I couldn't pull it outside of the limit. That'd be a problem, because the limit is dependent on n, right? Okay. So then this becomes, let's just do the algebra here then. So we end up with the limit as n approaches infinity of 2 over n times the sum of, if I square that, I'm just going to get 4I squared over n squared as I goes from 1 to n, right? Okay, so I didn't tell you guys something, because I made the choice not to spend a ton of time on this stuff. because I just don't want it. I feel like I want to get on, there's some stuff in calculus I want you to see that's more important. But if we had gone through every hoop here, I would have had you guys go through and by induction, find the answers to some sums, okay? Here they are. I'm just gonna tell you what they are. The sum of a constant as I runs from 1 to n is Cn. Makes sense. It's just C plus C plus C n times, right? No big deal. Okay, these are the ones that are a little bit tougher. You could have gotten these, but the sum of I as I goes from 1 to n is equal to n times n plus 1 over 2. And you would have gotten that. I would have, it's not a big deal. The sum of I squared as I goes from 1 to n is n times n plus 1 times 2n plus 1 over 6. And I hope I can remember this one. The sum of I cubed as I goes from 1 to n is n squared times n plus 1 squared over 4. I hope that's right. It's been a while since I've done these, so forgive me if I got that one wrong. You'll forget stuff too. That's right. That's right. Okay, so the one that we're concerned with here is this one. Right?
The I squared cubed is right. Is correct.
Yeah.
Okay.
Yeah, those are all correct. So this is the one we're concerned about. So and this is pretty handy, these summation formulas. So like we could say, for example, the sum of I squared from 1 to 100 is 100 times 101 times 201 divided by 6. And that's the answer. Okay, it works out that way. We'll harness that one, though, in our problem. So let's go back to our problem then. I could take this 4 over n squared and take that out of the sigma. Everybody agree? So then I'd end up with that's going to give me 8 over n cubed times the sum of I squared from 1 to n, which is that, right? Now watch the magic. This is really cool. So this gives us, I'm just going to write, when I say sigma, I mean from 1 to n. Okay. So then this looks like 8 over n cubed times, I don't even need it anymore because I've just got that, okay, times n, oops, this guy, n times n plus 1 times 2n plus 1 over 6. Okay, right? Okay, so watch what happens here then. If we do some algebra, I'm going to do a couple things just to save a little time. There's nothing you guys wouldn't do.
Yeah, definitely. That's what I was thinking. Yeah, don't think y'all is terrible color. It is.
If I just expand that out, if I multiply n times 2n plus 1, you guys agree I'm going to get 2n squared plus 3n plus 1 times n just raises the powers of n. So that's just going to give me 2n cubed plus 3n squared plus n over 6. Okay? Which is going to give me, if I distribute the 8 over n cubed to each term, let's just do it that way, I'm going to get 8/3 n cubed over n cubed, right? Everybody agree? Which is just 8/3 plus 4 over n. Everybody agree? because here I'm gonna get an n squared over an n cubed, right? Plus 4 over 3n squared. Everybody agree? If I simplify that by distributing and reduce fractions. Okay, let's take our limits. As n goes to infinity, what's gonna happen? What's gonna happen to that term? It's gonna go to 0, right? As n goes to infinity, that term's gonna go to 0. Remember what the answer was? 2 places it was 2.67. How about that? Hey,
That's interesting.
how about that?
I don't feel like the answer should be that simple.
It is though,
That doesn't make me comfortable.
right? And so that is, we did what we do. That's pretty cool. We just invoked the whole concept of a limit. And in the limit, as n went to infinity. Now, I mean, true, I had to throw in just a couple little extra pieces, but that's no big deal. I mean, I would just, if I had you do this on an assignment, which I will, I'll give you, you just know those, right? Okay? Those are in your book, right? Okay, but even better, can we come up with, how much time we got?
12 minutes.
12 minutes?
13, 12 and a half. Split the difference.
You want to
More than
estimate
10.
his
Upper and lower sum.
Okay, let's,
I'll 12 now.
there you go, upper and lower sum. Let's stop there. I don't want to get too far ahead of those guys, but that'll get you going. I'm gonna add,
Does Mac up Friday?